Thank you. Thank you very much for the presentation. So I will be trying to talk about the front end. It should be working. Yes, good. So I will be talking to you about, the cybersecurity, front-end cybersecurity, and how we can have some best practices and kind of the principles behind hardening your front ends. And I will be sharing the experience of the Finnish companion platform that I've built 2 years ago and what I can share with you. So I'll talk to you briefly about the story of Finnish companion and kind of the breach case studies, a few breach case studies, and then make the case that server-side monoliths might actually be safer, and then a few recommendations. So the Finnish companion is a powerful website and app that targets Finnish language learning pain points. When I first came to Finland, I met someone who had been 15 years in Finland yet didn't speak a word of Finnish. That got me questions, wondering why. And if you talk to anyone's experience about their Finnish language learning experience, they would describe it as this. Some jumps off the cliff, it's a nightmare, they crucify themselves, it's a complete nightmare. And there's actually, that's been established that the Finnish language is actually one of the hardest to learn in the world, just after Arabic, Chinese, and Japanese. And the reasons for that is because there are inefficient and scattered Finnish learning resources. There's not like one go-to Bible like other languages. The conjugation is very overwhelming. You just add one E or double or another L and completely the meaning completely changes. If you add just 2 dots, you literally mean something else. So näinkövarin means did I see wrong, or näinkövarin, should I marry grandpa? So if you're trying to talk to native Finns and you see kind of a confused face, just know that you're talking about something off. But also there are very limited practicing opportunities. Finnish people are very helpful, so they don't want you to go through the hustle of actually speaking Finnish, so they always kind of try to answer you in English, and that doesn't give you necessarily an opportunity to practice, but they are also introverts and shy. So the solution is the Finnish companion, a gym buddy that helps you lift a heavier weight long enough so that you can develop it yourself. That's a little bit what the Finnish companion does. And we have a suite of toolkits, and one of the most important one is this one. So we take long Finnish words and then we bring them down into readable. This is actually one string. This is one word that took 2 lines. And we input it into the platform, into the engine, and it goes from this to this. Lentokone, suihku, turbiini, motori, apumekaaniko, aliupseeri, oppilas. Turbine engine, something, mechanic engineer, helper, student, I guess. And then we have reverse conjugator, and then we have also an app. And we have also other tools that allow you to practice the conjugation. You just have to do a lot of drills, and you have to place the phrases and the verbs and choose the right forms, and you have to do that as fast as you can. And this is inspired by actually a certain technique and skill that you will find in common among tennis players and piano players and special forces. There's also a subtitle browser extension which does real-time translation of the Finnish public streaming service called Yle Arena. Most of their shows and streamed videos are not subtitles in English, so we did that, but also with real-time or near real-time constraints to be translating. So how did that all started? My background is actually from medicine. I'm a medical doctor and a neuroscientist by day, and then I previously was living in the Silicon Valley, working for Singularity University, and speak many languages and professional pianist. I, however, was coding since I was a kid, and this was my play toy when I was a kid. I was playing most of the time on Delphi 3 and Front Page and PHP 4, and that was the first Yahoo clone. I was trying at 13 or 12, I was trying to compete with Yahoo at the time. And then Flash Player, Director, and the likes, and that was kind of the inspiration. But it was all about the drills. And if you look at one of the best players in tennis history, when they do moves that look very graceful and natural, you would think, wow, how do they do that? There's actually an Italian word for this. It's called the sprezzatura, and it's just the art of doing many complicated tasks or skills in a very natural, nonchalant way. And this is what they have in common. But there are hours and hours and days and weeks and months and years of practice, regular practice. So it evolved from a spreadsheet into a Python extension, into an Anki, into an Airtable, and then it got better and better, and then we built the actual engine and readapted some other existing ones in Go, and then we started to implement just faster and faster and trying to go for performance. Using Cap and Proto instead of protobufs and things like that. We have an open API, and the more we start to kind of open to the world, and then we start to kind of see things happening. This is, for example, on the website where you can input a text, and it just gives it to you in a Finnish readable version as well. And there's this, the reverse conjugation kind of spotlight app. We also have a mobile app, an iPhone mobile app, and other mobile extensions. So everything was going pretty well. This is kind of the ecosystem that we have. It was, you know, a beautiful, not-for-profit kind of startup, beautiful story, covered by the media. We have 3,000 unique monthly users. Until one day, I just started to get few people telling me, messaging me that the dictionary results were not coming back. There was no results instead of this in very common words. So I got curious, and I quickly just went on to diagnose, and I realized that the dictionary results which were coming from the database were not coming back, or were coming empty, whereas the remaining engine properties and results were coming back. I quickly went into the database, and all what I found was a MongoDB looking like this. Pretty much asking me to pay for unencrypting my data. And the only thing that really triggered me and made me super angry was the don't panic. Your DB is safe and backed up. So that, I took it as a personal challenge that I would actually reverse all of that. And thankfully, we had enough logs and so on to be able to find what was coming up, where it was coming from. And it boiled down to that. MongoDB version 4.4. It turned out that despite that the code base was relatively implementing the best practices, it was actually during the deployment time we were using a kind of a Docker graphic user interface called CapRover, and it was deploying the MongoDB version 4 was by default, and we didn't pay attention to that. And at the time, the MongoDB standard version was 7. And there's actually a whole ecosystem of actors who run MongoDB ransomware as a service. And so we restore the data, put country blocks and so on, and that works. A more recent case now, in terms of front-end security, does anyone know this platform? Does it sound or look familiar? So it's a platform that's been started by someone that is very, very controversial for many, many reasons. And turned out that his platform got hacked, and 800,000 users' identities and emails were leaked, and they are still publicly available. It happened during his live streaming. He was live streaming and had a platform, a Discord clone, and the people started to see emojis changing and so on, and it was clearly, it was a targeted attack. It wasn't just something random. Around 30 gigabytes or 35 gigabytes of his data that he was actually monetizing, including courses and videos, were released publicly available. And he sells all of those memberships for quite some money. So the damage, the financial damage done to him, as well as the reputational damage, was actually very significant. So how did that happen? This started when we look at his tech stack. He was using the regular TypeScript and Tailwind and so on. And then if you look at his architecture, on the front end, he was using Next.js for the sign-up process. And then on the back end, he was using Rust Rocket, which kind of caught attention. Why would you actually use Rust for a backend? It's really, you really have to want to work hard to do a backend in Rust. You can do something faster and so on. But actually, when you look into more in detail, you see that he was using the 0.5 version at the time as well, and all of the details of his backend were actually just available. And then what happened was that whoever targeted him, they just went on the browser console, typed something here, =1, they made it true, and suddenly they went into full God mode into the platform. So they were able to silence people. That was from the client side. They were able to just ban people. They made everything free for whoever was there, upscaled the status of the participants as well. It was a complete chaos. They were injecting hidden scripts that would crash the client side, which would also persist. So even if they would leave the browser, refresh, go from the mobile, same thing. Turned out that the reason was that there was unobfuscated JavaScript code comments, which really facilitated the reverse engineering, but also there was a critical unpatched version that he was using of his backend. So there were actually pre-existent ingredients. And this same pattern actually is now becoming more and more prevalent. And the issue is that it's being weaponized for geopolitical impact. Just a few months ago, actually, there was a Next.js middleware bypass critical vulnerability, which the National Cybersecurity Center in the UK had actually warned about. And what happened, it was affecting the versions 12, 13, 14, up to 15. And literally, this is like a dream case scenario for any hacker, is to skip the middleware entirely. So how did they actually do that? So they start by looking for a root. Usually they just keep scanning and trying, trial and error. For admin, if they are redirected to the login, that's already very likely that it's the middleware. And then they send requests to the admin with a very specific crafted header that would simulate a recursion depth. That tricks Next.js into thinking it's an internal sub request. And then it just renders /admin without verifying the login. It does return the HTML, and that's it. So you would say, okay, well, they just got the HTML, so what? That's just pages. The issue is that now I was actually very, very cringed and surprised that there are repos that would allow you to just run a Python bot which would scan for those vulnerabilities. And then what happens is that they actually also were able to go beyond the read-only mode, which means that they would persist the state, and that's what happened to the Andrew Tate platform, where they were actually persisting the changes. So they can also call admin APIs with the same spoofed header, and that would mean that they would be able to trigger admin delete and other actions if they hit the right endpoint. So the lessons from this case particularly is that the middleware is server-side but trusted client-side input, and that was a huge critical mistake. And then it should have been enforcing back-at-side authorization on privileged inputs. Another very tangible example is Roundcube and Proton Mail, which exposed government emails. What happens is that Proton Mail has this reputation, and other mail clients as well, web mail clients, have the reputation of being extremely safe. They do end-to-end encryption and so on. So the encryption side is good. And this is how you actually might end up into having press headlines that look like this. I will give you an example. that is not linked to this, but it's the same principle. With the Roundcube XSS attack, what happened was that that particular attack was targeting Ukrainian military, Georgian defenses, and EU ministries. That persisted in the browser and would also steal the emails and the contacts from the inbox that is showing on the client side. And the root cause was that the desanitization after sanitization was happening. Of course, you can look into the details of the whole thing, but what was happening is that they were modifying the sanitized HTML, and there was a bad regex logic. And then what the attackers were doing is that they were attaching a malicious attachment, which was not verified, and they just hijacked the page persistently. And they would run those workers as well. They were doing that through workers, and that workers would run every time the page was there. And they were able to execute payloads through the email attachments. So what I would say for this particular case is that don't post-sanitize mutations, and then make sure that you are using DOM Purify on the client side, and always, always, always isolate anything that is email content in sandbox iframes. So why would I prolixize for the monolith mindset? Of course, it's not a bullet, a magic bullet, so it has pros and cons as well. But I would argue that the monolith server-side first architecture protects from exposing the client logic and APIs. It relies mostly, for example, the difference I would say with the client side is that nowadays the modern front ends actually rely too much on the client side input validation and we tend to forget that there must be also server-side validations. It's very easy also to tamper with that using the browser dev tools and other tools as well, and just start to altering parameters and so on the client side. There's also a huge debate about the GWT tokens versus using actually sessions and cookies. GWT-based single-page applications are very susceptible to DevTools tampering. And you would say, well, this is like a little bit overstretched. Well, actually, there was a case that happened recently where the client-controlled auth was very fragile to the point where it was a huge, huge, huge scandal happening from a very major big company like this one. They didn't enforce auth on the front end. There were no gatekeepers. The critical endpoints were responding without validation. This is a big company like that, so it happens, yes. If it was a monolith, I would argue that the auth logic would stay on the server side, but also you don't rely on a JS layer. And the good thing is that those frameworks, monoliths, actually use CLI scaffolds that would avoid the coding errors and the generators. And that's what I would argue made, for example, 10 years or 12 years ago, Ruby on Rails, the startup platform to be used back at the time. But today we have other alternatives that are also faster and more efficient. So we moved in the Finnish company, for example, our student portal, we're using plain flat Django. We started with Flask and then Django, and just if we needed some client-side interactivity, that would be HTMX or jQuery, for example. Those are the main monoliths that I would argue are good. For example, this one in particular is to watch very closely, Lucky. It uses Crystal language, which has the same syntax as Ruby on Rails, but is compiled and compiles into a binary. Most of those monoliths, all of them deliver HTML while keeping a client-side interactivity. Jussi was talking earlier about Rust, for example, and that the fact that it didn't necessarily improve a certain aspect of the attacks. I agree with that. It's all based on the architecture. Safe memory, safe languages are not also a magic bullet. That was after the report that was published by the NSA recommending to use memory safe languages. But you would tell me, okay, well, I still need the reactivity and interactivity. So how could I do that? Well, those monoliths also have those kind of gluers that put themselves in between the front end and the back end, such as in Inertia for Laravel, that allows you to use React and Vue with the Laravel full stack. There's Livewire as well, and others. Quick is particularly interesting. And then I would argue this is a prototype that we've done with Quick. What was good about it, and I actually dived into Quick last year when I spoke here, and there was someone from the Quick team that just explained to me how it worked, and I got curious, and this is what we did actually. We built an interface that would do very quick auto-suggest. That auto-suggest is actually hitting a Go binary through gRPC in the backend that is not exposed at all. And if you look into the console, then you would realize that the only thing that is being emitted and received are chunks. So we are actually reducing the exposure surface. If you're an attacker, it might be quite complicated to guess what's the schema and what's going on and what's coming back, and it happens by chunks. So this is the architecture. The user goes on the browser, they interact with the page, they start to interact, and it relies on the Quick's server function, which is kind of hydration on demand. We do validate the input, but then we hit on the back end, and it's internal, it's not exposed, a gRPC binary that is written in Go, return the response, and then Quick handles it. So there's no REST API, no exposure. Everything runs in the back end, and we communicate internally, and everything is serialized through Proto as well, the contracts. So we do also have back-end validation, which were lessons learned from those proto-mail, for example, to always control the MIME tape response and so on. I would conclude this talk with few stats, because I think it's very important that it might seem very, very, very obvious that you shouldn't hard code the credentials, but actually there were nearly 23 million secrets exposed in GitHub repositories last year. Around 33.4 million Authy platform phone numbers were leaked via unauthenticated API. That means if you get phone numbers, that means you can spoof SIM cards. That means you can steal identities. So just an unauthenticated front-end or back-end API has consequences that are extremely heavy and cost money. Jussi has spoken about the dependencies, and then also CMS vulnerabilities. We still have to keep in mind that 80% of WordPress websites are still vulnerable to WP-admin/login. Those are very much compromised also through plugins. Coming back to the Andrew Tate platform, that schema, for example, was exposing this. And you just visit this website and then you realize it's still open. That was actually a screenshot from today. And he's using Directus CMS. So this, despite that fact, well, you might argue that, well, you're going to have to, you might not log in, but it still gives information. And I would posit that we need to actually keep it obfuscated. Framework misconfigurations. So again, there's no one magic bullet solution, even Laravel also, with bad configurations, so best practices. And API endpoint exploits are very common. And then last thing, I would just quickly touch upon the LLMs. Jussi as well was talking about them in detail. This very interesting article that was talking about someone who was just reviewing his experience. And there's what can happen when you are over-relying without intentionality on the LLMs to generate code. You end up having with Phantom best practices, for example, where you get suggestions that actually don't exist or are not relevant. A lot of hallucinated contexts, where if you keep going and going and going, then the LLM starts talking about things that you didn't even talk about in the first place. And then the overconfidence in the tone, it creates an illusion of comprehensiveness. And in fact, the people who were relying on the most confident statements by LLMs happen to be actually the most vulnerable. So I would argue that keep in mind that also different LLMs have different hallucination rates or rates. So stay updated on those rankings as well, I would recommend. But if there's one slide as a key takeaway, I would say that zero trust principle is what needs to prevail in the front end. That's my argument. I would say that just assume that the client is hostile to you, it's overly exposed. It's just like you're leaving something in the street and anything can happen to it. So that would be the kind of the mindset, and it's supposed to be attacked and untrusted unless otherwise proven. And then I would say if you have the possibility to go on binaries, for example, or use the monoliths, I would recommend that. I was quite surprised to test buns. Bun runtime, single file executable is just amazing. So you can actually just compile a whole thing into one binary and ship it. That also adds a layer of security. With that, I'm happy that I got to share with you the experience of Finnish Companion and hardening concepts, and more importantly, I hope that you've learned also to pronounce the longest word in Finnish. Lentokonesvehkuturbiini apomekaanikoaliopseerioppilas. Thank you very much.